Welcome back to Topics in Statics. This time we're going to talk about two different topics. First, calculating the moment when I know what the axis of rotation is going to be. Or it may not actually be rotating, but the axis that I'm calculating about, rather than just calculating about a point. And then we'll talk about the moment of a force couple. So moment of a force about a specified axis. So here's a guy changing his tire. He's got a lug wrench. He pulls up the force F. In what direction does this thing want to rotate about? If I just do R cross F, here's R. Just calculate what R cross F is. I get an axis that points down this way. There's the moment about O. It's pointing in some weird direction. However, it can't rotate around that axis, right? The lug nut is threaded along this shaft, and the shaft points this direction. And so it has to rotate around that axis. There's no other way it can rotate. So as a consequence, I have to calculate what's the moment about that axis. And so I've written a scalar analysis over here, and it's very confusing. Basically, this is saying the moment around this axis is equal to the force times some distance along that axis. So here's the d I'm talking about there, the dy, the perpendicular distance. All right, I can do this in a vector analysis. The moment about O is R cross F, but then I'm requiring it to rotate about a specific axis. So what I have to do is find the component parallel to that, which means I need to dot it with a unit vector along that direction that it's going to rotate, the moment about the axis. So I get a dot product of a cross product. So I take a unit vector and dot it with a cross product. That's the thing in math you call a triple scalar product. The result is always going to be a scalar. It's going to be the magnitude of the moment about that specific axis. And how do you calculate it? Rather than having, I do the same thing I did with a cross product, except now I take the unit vector in the x direction. Right, these are the components. This is horrible notation. That's horrible too. So just take that determinant the same way we did in the moment video, except now instead of having I hats, j hats, and k hats, I've got numbers up here in this top row. Right, those are the components of a unit vector. So it could be, who knows, 1/2. Except that doesn't add up. 1 over the square root of 2, 1 over the square root of 2 is 0. Those are the components of that unit vector. And so when I multiply all this together, what I get is just a number at the end. The main thing we want to talk about here is going to be the moment of a couple. Right? A couple is two equal, opposite, and non-collinear forces. I call this a couple moment, or a couple, or a force couple. All right, the moment is a couple. The moment is a couple moment. Lots of terminology there. Couples have several very important properties, and they have lots of important applications. Right, key is two equal, opposite, and non-collinear forces. So if I was to draw them, here's some object, and I've got two forces acting on it. here's one force, and here's the other force. And the trick is one of them's the opposite of the other, and they're not collinear. They don't add up to zero because, or they produce a moment, so they're not back to back. So here's a basic picture. The interesting thing here, what this picture is showing is how to calculate the moment of each of these forces about O. And the interesting thing you get is that it doesn't depend on where the point O is. What it depends on is the force, write one of the forces as a vector, and then draw a vector that points from the line of action of one force to the line of action of the other force. And I use that for my R. And so that's what this is saying here, that this R cross F, here's R. It doesn't have anything to do with the point O. So I can calculate the moment about any point I want, but it doesn't depend on where that point is. So what that tells us is that a moment of a couple is a free vector, right? It can act at any point since M just depends only on the position vector directed between the forces rather than the position from where the axis is. The couple moment is independent of the axis of rotation, has the same magnitude for any rotation axis. It's a free vector, produces the same rotation no matter where it's applied. The magnitude of the couple moment is the force F times the perpendicular distance between the two forces. Perpendicular. All right, a vector formulation, to calculate the couple moment using a vector formulation, R must point from any point on the line of action of one force to any point on the line of action of the other force. Two couples are called equivalent if they produce a moment with the same magnitude and direction. Since couple moments are vectors, you can add them as vectors to find the resultant couple moment. And that's it. That's all we got to say about couple moments for this time. Next time we're going to start putting all this stuff together and applying it to a simple object so that we can get to equilibrium of that object. Until then, that's it.